consider a parabola with an equation shown below, and you can see this is not standard form for a parabolic equation. So first thing we have to do is put it in standard form, and then we can use that standard form equation right here to learn all these other things about the parabola that we need, the vertex, the focus, the focal length, etc., and eventually we can graph it. So let's start off characterizing what kind of parabola we're talking about here. I know it's a parabola because I have an x squared there and a single y right here. There's no y squared. So when you have just x squared, what that means is we're dealing with a vertical parabola. So what I'm going to do is try to arrange a perfect square on one side with the x and a linear term on the other side with the y. The way I'm going to do that first is I'm going to keep my x's over on the left, and I'm going to pull everything else onto the right side. So that makes, let's see, negative 4y plus 7. And the next thing I need to do is create a perfect square out of this. So x squared plus 6x is not a perfect square, but with some practice, you'll see that there is a perfect square if I add 9. Okay, what I'm really doing is, remember the old formula, h equals negative b over 2a, right? Completing the square, that's what I'm doing. So I'm adding 9 to this right side, and that means I also have to add 9 to the left side. All right, I mixed up my left and right, whatever, we're moving on. So what is x squared plus 6x plus 9? Well, that is just x plus 3 squared. Okay, that's why I chose 9. I divided my linear coefficient, this 6, by 2, and that gave me 3. I squared 3, and I got 9. So what do we get on the right side? Well, negative 4y. It doesn't look like a whole lot now, but maybe something nice will happen. That factors. I can pull out a negative 4, and what's left is just y minus 4. So if you look at what we've got here, all of a sudden, well, that's pretty good. That's the standard form equation, okay, that we're talking about right here. And you can see, yes, it is definitely a vertical parabola. So let's start pulling some things out of this, okay? If you remember what the standard form equation looks like, it's x minus h squared equals 4 times p y minus k. Okay, so h is the location of the vertex in the x-coordinate. And for us, you can see that's going to be, looks like negative 3 in the x-coordinate. That's h. And k, according to this equation I'm looking at right here, is 1. So negative 3 comma 1 is the location of the vertex. No, what am I talking about? It's 4. 4. I just misread that. I'm looking at this number right here. There's my 4. Okay, so the focus is located, well, let's think about that. Where's the focus? It's not apparent from the equation where the focus is located. So we're going to have to do a little digging here. If you look at what P is, okay, P is equal to negative 1, according to this equation. That means if I have a vertical parabola with a vertex at negative 3 comma 4, where am I looking at here? That's like about here. There's the vertex. And because it's a vertical parabola, it has to open up or down. Well, this negative value on P means we're going down. So it's going to look something like this, right? We'll get a little better sketch in a few minutes. Now the focus is located kind of on the inside portion, somewhere in here, right? The parabola has to wrap around the focus. Since P is negative 1, that's going to place the focus actually 1 unit down exactly from the vertex, okay? So that's a start. I don't exactly know the shape of this parabola yet, but that's a pretty good start. And I'm going to say the focus is located at negative 3, same x value, but 1 unit lower in y, so 3. The focal length, as I've talked about, remember that's the absolute value of P. Okay, so that's going to be 1 for us. You can never have a negative focal length. And the focal diameter, that is just the absolute value of 4P. Okay, so that's going to be 4. The equation of the axis of symmetry, well, where does this look like it's symmetric around? If you just draw a line right here, you can see it's a mirror image on both sides, right? That's the axis of symmetry. So that is a vertical line. So we say x equals, and now you give it that x coordinate, negative 3. And the equation of the directrix, well, where is the directrix? This is important to remember. The directrix is perpendicular to the axis of symmetry, right here, and it is the same distance from the vertex as the focus is. It's just on a different side. So this is going to be y equals, and it's going to be above the vertex because this parabola opens down. So this guy is going to be y equals 5, looks like. Okay, so now I have all the important stuff in this upper portion, and let's do a slightly better job of drawing this thing. I can see my vertex and my focus, and I know that the focal diameter of 4 is this distance right here. That is the length of the lattice rectum. And the usefulness of that measurement, the lattice rectum, is that you can draw from the vertex to the lattice rectum, and that sort of defines how wide this parabola is. And this is, I don't know, typical looking parabola. It opens down. And yeah, I think that's all there is to this one. Now, a couple points. If P had been positive, this guy would have opened up, right? You would have had an upward facing parabola. And if y squared had been in this equation instead of x squared, you would have had a parabola that opens left or right, like so. But we'll get to those in a different video.